So on test review number 4, it says solve for x, right? 6 square root of x plus 2 minus 6 square root of 3x plus 6 equals 0. I think the easiest thing to do here is to add this one, this negative 6 square root of 3x plus 6, over to the other side. So that's what I'm going to do. I'm going to set this up as 6 square root of x plus 2 equals positive 6 square root of 3x plus 6. So when I add it to the other side, it just gets rid of that negative. And now the easiest thing to do from here is just divide by 6 on both sides to get rid of those 6's. To leave it as the square root of x plus 2 equals the square root of 3x plus 6. Now it becomes a pretty simple problem. If you just square both sides, it'll get rid of both the square roots. So that's what I'm going to do. I'm going to square both sides. That's going to leave me with x plus 2 equals 3x plus 6. And at this point, it's simply an Algebra 1 problem. So all we need to do is subtract x from both sides and subtract 6 from both sides. So that's what I'll do. 2 minus 6, that's negative 4. And that equals 2x. And then, of course, when you divide by 2 on both sides, you've got x equals negative 2. But you should always double check that answer by plugging it back in. So negative 2 plus 2 is 0. The square root of 0 is 0. And 6 times 0 is just 0. Minus, let's see, 3 times negative 2 is also negative 6. Negative 6 plus 6 is still 0. So this is essentially 0 minus 0 equals 0. That's the correct answer. X equals negative 2 is the correct answer here. The next one I'm going to do on the test review is number 9, which is deceptively simple. It says to rewrite in exponential form. And on the test, when you see this problem, unless it says to rewrite and extract all roots, you don't need to worry so much about simplifying. All that I want you to do here is realize that you can rewrite this cube root as an exponent. So when I put this thing in parentheses, 64 x to the third, y to the 6th, z to the 10th, oops, and put that 1/3 up in the exponent there. That's what I want you to realize. And then you can distribute that 1/3 to the 64, to the x, to the y, to the z. So you can rewrite that further as 64 to the 1/3 power times x to the third to the 1/3 power times y to the 6th to the 1/3 power times z to the 10th to the 1/3 power. And what you need to remember to be successful here is that whenever you have an exponent raised to an exponent, you simply have to multiply. But before I do any of that, 64 to the 1/3 power is the same thing as the cube root of 64. And of course, the cube root of 64 is just 4. And then x cubed to the 1/3 power, 3 times 1/3 is just 1. So this is x to the first power, or just x. Y to the 6th to the 1/3 power, 6 times 1/3 is 2. So that's just y squared. And then finally, 10 to the 1/3 power is 10 times 1/3. On this one, you can go ahead and leave that as 10 over 3. If it had said to extract all the roots, like it will later on the test review, then you would want to simplify that further. But for now, I think this is okay. So that's number 9. And I'm going to skip ahead to number 11, which is another solving problem. And on this one, we're solving for x. What you'll want to do is realize that this 1/2 power is the same as the square root. So if we square both sides, we can get rid of that 1/2 power. So that's what I'm going to do. I'm going to square both sides, and I'm going to get x squared equals 3x squared plus 14x. So what we've done is we've gotten rid of that 1/2 power over there, And since we had to square it to get rid of it, we've got an x squared over here. Now we just need to solve it. And in order to solve a quadratic, I know it's quadratic because it's got a squared on one side. I need to get a 0 on one of those two sides. I'm going to choose to subtract x squared from both sides. To get 0 equals 2x squared plus 14x. Now, there's a few different ways you can solve this thing. You can graph it, see where it crosses the x-axis. You can use the quadratic formula. But the way that most of you are going to solve this is by factoring. And we can pull out the greatest common factor of a 2x. And when I do that, I'm left with x plus 7. So I've got two solutions here. I've got 2x, I've got x plus 7. I'm going to set them both equal to 0 and solve to get x equals 0 and negative 7. But we need to double check that both of them work because one of them might be extraneous. Remember that fun word, extraneous? When you plug a 0 in there, 0 squared is 0, times 3 is 0, plus 0 is 0. So 0 plus 0, the square root of 0 is still 0. That equals 0. The 0 checks. That's a good one. The negative 7 is, when I plug that in, negative 7 squared is 49. 49 times 3, that's 147. Right? Plus 14 times negative 3. Now I'm testing myself. Oh, I've got a calculator here. 14 times negative 3. 147 minus 42 is 105. So we're getting some funny answers here. 105, the square root of 105 is definitely not negative 7. Negative 7 doesn't check. That's an extraneous. So the only solution here is x equals 0. And all I did was to plug them back into the original function to double check that. All right, I said I'd also do number 12, and of course I didn't leave myself any room to do that. But, hey look, now I've got room. Write the inverse of the function f of x equals 10x squared plus 30x. Remember, to find the inverse, you just flip the x's and the y's. So that's the first step. X equals 10y squared plus 30. All you'll need to do from here is get the y by itself. The first step, take care of that plus 30. The opposite of plus 30 is minus 30. So we got x minus 30 equals 10y squared. Now this is the part where people always get tripped up. They always want to take the square root right here. Don't do that, because you have to take the square root of the whole side. And we don't want to end up with the square root of 10. So I'm going to recommend we divide by 10 on both sides first to get x minus 30 divided by 10 equals y squared. Now there's a couple different ways you can write that. You can leave it just like this, or you could rewrite it as x divided by 10 minus 3, because 30 divided by 10 is 3. But it's fine if you want to leave it just like that. That's okay. That's acceptable. The last step, of course, is to take the square root of both sides, which I'll now do. Y equals the square root of x minus 30 divided by 10. And that whole thing right there is underneath the square root. But there's one thing I've forgotten to do here. Whenever you take the square root, there's always two solutions. So we got to put the positive and negative in front there. That's right. And since it's not a function, because of the positive and negative, I'm not going to write it in function notation. If it was just the positive in front or if it was just the negative in front, I change that to f to the power of negative 1x, or f inverse of x. But since it's not a function, we'll just leave it just like that right there. The next one I said I'd do is number 19. So I'm going to flip over there. And number 19 is a simplifying radicals problem. And remember that you can only combine radicals if they have the same thing underneath the root there. Since that's a 5 and that's a 125, you'd say you can't combine them as they are, but there might be a way to simplify that 125 to change it so that we can make it root 5. In fact, what we can do 8 root 5 minus 10 times 125 is simply 5 times 25. So I'm going to change that to the square root of 25 times the square root of 5. 25 times 5 is 125. And of course, the square root of 25 is just 5. So that's 10 times 5 right there. That's 8 root 5 minus 10 times 5 is 50 root 5. And then from there, all we want to do is subtract 8 minus 50. It's negative 42 root 5, which is the answer. And I've got time to do one more, which will be number 22. And so I'm going to flip over to that. And number 22 is a difficult problem. When you're simplifying this thing, what you want to do is multiply the top and the bottom of the fraction by the conjugate. Now the conjugate is the same, this 8, this root 3, this 8, this root 3. But instead of it being a minus in there, we want to change it to a plus. So you only change the operation in the middle. So change it, if it's a plus, make it a minus. If it's a minus, make it a plus. That's what I'm going to do. I'm going to do 8 plus root 3, 8 plus root 3. So on the top there, we're going to have to distribute 2 root 3 to both sides, or sorry, to both terms. So that's going to be 2 root 3 times 8. 2 times 8 is 16 root 3. 2 root 3 times root 3. Well, root 3 times root 3 is root 9, which is 3. So this is just 2 times 3, which is 6. That's the top. On the bottom, we're going to have to FOIL this out, unless we're smart. The whole point of multiplying by the conjugate is to get the middle terms to drop out so that we don't have any square roots in the answer. Because the whole thing is we don't want to have any square roots on the bottom. So we're going to FOIL, but we actually don't have to worry about the O or the I parts in the FOIL because those parts always cancel each other out when we multiply by the conjugate. So we actually make this really simple. We just do 8 times 8, which is 64. And then negative root 3 times positive root 3, which is negative root 9, which is just negative 3. That's really bad FOILing, but you can do it when you're multiplying by the conjugate, because the two middle terms always drop out. That's how smart people do it. Now this is almost all the way simplified. There's just one last thing we need to do in the denominator there, and that's change it to a 61. So this is 16 root 3 plus 6, all divided by 61.